Assalamualaikum and hi everyone. We are from this group and we like to present our summer for the subject mathematical logic and proving technique. For this presentation, the topic we will be presenting is logical connective, where we will explain the basic concept, definition, and example to help you better understand how logical statements are connected and evaluated. The presentation will be delivered by four group members, which is myself, Nobatu Saparhan, Ani Yusri, Aida Ilhan, and also Hairatul. Each of us will take part in explaining different sections of the topic to ensure the presentation is clear, well structured, and also easy to follow.
Starting our presentation off with statement and logical connectives. First off, what is a statement, or otherwise known as a proposition? It is a declarative sentence that is either true or false, but never both, except in certain circumstances, which we will get into later on in the video. A primary statement is a statement that can be represented by a variable, for example, P, Q, R, S, or their lowercase counterpart. The truthfulness or falsity of a statement is called its truth value. A true statement has truth value T or 1, whereas a false statement has truth value F or 0. Statements can be combined by logical connectives to obtain compound statements. The truth value depends on the type of connectives used. Here are the logical connectives and compound statements, followed by their respective symbols. Starting the list off with a conjunction. The conjunction of P and Q is the compound statement P and Q, denoted P and Q. It is true only if both P and Q are true.
Hi everyone, in this slide, I will explain about disjunction, which is the logical operation or represented by the symbol V. The main concept of disjunction is P or Q is true if at least one of the statements is true. It is only false when both statements are false. Now, let's look at the truth table. First row, P is true, Q is true. Since both statements are true, P or Q is true. Second row, P is true, Q is false. Even though Q is false, P is still true. So, P or Q is still true because at least one statement is true. On the third row, P is false, Q is true. Here, Q is true. Therefore, P or Q is true. On the first row, P is false, Q is false. In this case, both statements are false, so P or Q is false. Conclusion: disjunction or the OR operation is true whenever at least one statement is true, and false only when both statements are false.
Next, I will explain about negation. The negation of statement P is written as not P and is denoted by the simple negation P. Negation means reversing the true value of the original statement. This means that negation P is true when P is false and negation P is false when P is true. Based on the truth table, when P is true, negation P is false, and when P is false, negation P is true. This shows that the negation of a statement always has the opposite true value of the original statement.
This slide explains implication, which means if something happened, then something else happened. For example, if statement P is true, then statement Q is true. Here, statement P is called the premise, which means the condition. Statement Q is called the conclusion, which means the result. Now, let's look at the truth table. First, if statement P is true and statement Q is true, the implication is true. Second, if statement P is true but statement Q is false, the implication is false. This is the only situation where the implication is false. Third, if statement P is false and statement Q is true, the implication is true. Fourth, if statement P is false and statement Q is false, the implication is also true. So, in conclusion, the implication is false only when statement P is true and statement Q is false. In all other situations, the implication is true. Next is a biconditional statement, means if and only if. It is true when both statements have the same true value. This means it is true when both are true and also true when both are false. If one statement is true and the other is false, then the biconditional statement is false.
Okay, now I will explain the three important concepts in logic under truth values: tautology, contradiction, and contingency. First, tautology. A tautology is a proposition that is always true, no matter what is the true values of its component statements are. This means that in the truth table, the last column contains only T, which stands for true. For example, the statement P or not P is always true. If P is true, the statement is true. If P is false, negation P becomes true, so the whole statement is still true. So a tautology can never be false. Next, contradiction. A contradiction is a proposition that is always false, regardless of the truth values of its component statements. In the truth table, the last column contains only F, which stands for false. An example is P and not P. If P is true, negation P is false, so the statement is false. If P is false, negation P is true. Still false because both of parts must be true for a conjunction statement. So a contradiction can never be true. Lastly, we have contingency. A contingency is a proposition that can be true or false, depending on the truth values of its component statements. In the truth table, the last column contains a mix of T and F. This means the statement is not always true and not always false. It depends on the situation. To conclude, tautology is always true, contradiction is always false, and contingency is sometimes true, sometimes false. That's all for this slide. Now, we are looking at an example of an implication statement. The statement given is, if Ellen wants to succeed, then she must put in a lot of effort and seize every opportunity. Let's define the simple statements. P. Ellen wants to succeed. Q. Ellen must put in a lot of effort. R. Ellen must seize every opportunity. Question 1. State the using only if in words. The answer: Ellen wants to succeed only if she must put in a lot of effort and seize every opportunity. Question 2. State the implication using if in words. Answer: if Ellen wants to succeed, then she must put in a lot of effort and seize every opportunity. That's all for example 1.
Alright, let's move on to the next part. Here we are asked to find the converse of the implication word. Remember, the converse just means we swap the if and then parts. So the converse will be, if Ellen must put in a lot of effort and seize every opportunity, then she wants to succeed. We are just switching the position of what comes after if and what comes after then. That's all for this part.
Moving on to the fourth and last question. The fourth question asks if P implies Q and R is true, and Q and R is false, then the truth value of P is? For a statement to imply another false statement, the prior statement must also be false. Thus, the answer is false. For the last question, what's the negation of the implication P implies Q and R in symbolic form? The negation of an implication P implies Q and R is P and negation Q and R, which we can imply De Morgan's law to transform it into P and negation Q or negation R.
For example 4, the question asks to construct a truth table for a given logical statement. To answer this question, we construct a truth table in a systematic way. First, we list all possible combinations of true value for the truth statement, so that every case is considered. Next, we determine the negation of the second statement for each row in the table. Then, we combine the first statement with the negate second statement and decide whether that part is true or false. After that, we combine this result with the third statement to obtain the true value of the entire statement. The final column of the truth table shows the overall true value of the given statement for each possible case.
Alright, so wrapping up, logical connective are basically little tools we use to connect statements and show how they relate to each other. Think of words like and or and if then. They might seem simple, but they actually help us reason clearly and figure things out step by step. Solving logic problem or understanding argument become way easier since once you get the hang of them. And that's pretty much the main idea behind logical collective. And that's all from us. Thank you for watching.